Hello everyone. Welcome to the online advanced training program on net zero climate emissions, which is focused on the role of nanotechnologies for advanced energy generation, conversion, and storage. So my name is Guilherme Gaspar, and I'm one of the team members responsible for the scientific coordination and organization of this training. So I'll be moderating day one together with Killian Lobato, my colleague, and I would like to remind you that you should mute your microphone so that we don't have any background noise. And a good and important thing is that you should write down your questions to the speakers on the Q&A chat so that both of us can actually ask the speakers, and that you will have then your answer to the question. So just a quick start. So just on the team, there is organizing team. There is Killian Lobato from Faculty of Sciences at University of Lisbon. Then we have Brian from the University of Texas at Austin, Carla Silva from CITEVE, myself from Faculty of Sciences as well, and Paulo Ferreira from IST and INL. So then we have the technical coordination of the UT Austin Portugal Program, where you have Sheila and Vera Pinto in the back office. So the agenda for the seminar very quickly will be day one focused on the Green Deal. Then tomorrow we'll have a day focused on photovoltaics. Day three will be on energy storage, mostly focused on electrochemical batteries and supercapacitors. And the last day will be mostly dedicated to H2 generation and storage. So regarding today, it's going to, as I said, it's going to be moderated by me and Killian. This is the agenda. We will have Claudio that will start the session with a title from COP26 to Climate Pact Ambassadors. Then we will move to our colleague Antonio Valera, which will mostly talk about models for decarbonization of road transport. After that, we have GR Di Chazo from University of Texas, which will help us to understand the American perspective of the Green New Deal. After him, we have João Ribao, which will show funding opportunities in nanotech and energy systems at the European level. At the end of the day, we'll have a roundtable session, 30 minutes, where we have the intervention of Peter Lund together with all the other speakers. So that's the agenda for today. So with this, I'm gonna stop sharing my screen, and I'm gonna introduce the first speaker, Claudio Pistida. Welcome, Claudio. Claudio is the group leader of materials development at Helmholtz-Zentrum Ehren in Hamburg. Is lecturer in materials technology at Helmut Schmidt University and is a European Climate Pact ambassador. He has interests in several different aspects of material chemistry, including micro and nanostructured materials, multi-component hydride systems, and he works on research on and development of high-performance, low-cost hydrogen storage systems made from recycled industrial metal waste. Dr. Claudio holds a PhD in material science from the Technical University of Hamburg in Germany. So Dr. Claudio, so the floor is yours. Thank you very much.
Thank you, Guilherme, for the kind introduction. I will share my screen now. Just let me know if you can see the screen.
Yes, we can see it.
Good. So good afternoon, everyone. So once more, my name is Claudio Pistida, and I come from the Helmholtz-Zentrum GISTAT. So today I'm going to speak about climate change and what we are doing for fighting climate change and to adapt to the consequence of climate change. So this presentation, it's divided in several parts. Now I will start with giving a little bit of background why climate change and when it started. Then I will discuss briefly what was the Paris Agreement. So one of the first meeting where it has been agreed to jointly with between several countries fight the climate change. No? Then we will move to the most recent climate pact, the Glasgow one. And then we will see what is the role of the European Climate Pact in fighting the climate change. And finally, I will conclude discussing about the role that Climate Pact ambassador plays in fighting the climate change. Now, background. So, as you all may know, since the last 150 years, the world, humankind faced an almost uninterrupted period of well-being and growth of life expectation. Now, this is mostly due to the fact that humankind had access to electricity, transportation, heat, and communication. But what is sitting behind these four main driving factor of the increment of the life quality of the humankind? Well, what is lying behind is the access to cheap and abundant energy. Cheap and abundant energy that comes from fossil sources like coal, oil, and gas. Now, if we look at this graph here, so this graph shows the global primary energy consumption divided by source in the last 220 years. So if we look until 1870, so the period of the second industrial revolution, the global primary energy consumption increased with a slow pace. No? After this, after 1870, it started to grow exponentially until it reached the actual levels. So we are here. As you can see, the global primary energy is fulfilled for almost its totality by fossil fuel source. You can see here that the most important is coal, followed by oil, and then natural gases. So this is not exactly a good news. Now, we have to consider that the world energy demand is somehow connected with the world population, if not directly, but it is strictly connected. So in this graph, what you see is the trend of increment of the world population in the period 16th century, the 21st century. So what you see here is that, again, we had in the last 100 years an increment of the world population of by a factor of 4. No? However, if we look at how the primary energy consumption increased in the last 100 years, we see that it increased by a factor of 24. So much more than the increment of the world population. Now, if you consider that we are sitting at this point here, now the actual world population is around 7.7 billion, and is foreseen to grow to 8.3 billion by 2030 and 9.7 billion by 2050, we expect an increment of the energy demand by a factor of 4.5. And this, it's actually not a really good news if we consider that if we don't change anything in the way we live, most of the energy will be provided from fossil fuel sources. But why such fossil fuel sources are so problematic? Good. So let's think about the CO2 concentration in the atmosphere. The first time that has been recorded was in 1958 by Charles David Killian, that measured the CO2 concentration in the atmosphere as 317 ppm. So this is a chart that shows over the year how the carbon dioxide emission and atmospheric concentration changed in the last almost 300 years. So here is the point in 1958 when Charles David Killian measured the concentration of CO2 in the atmosphere. So 1870 is the date of the Industrial Revolution, Second Industrial Revolution. As you can see that, already in this period here, the concentration of CO2 in the atmosphere increased quite a lot. But we have to see that in the last 60 years, it increased dramatically. And if we give a close look in the recent years, since 2017, the concentration level of the CO2 in the atmosphere settled for above 400 ppm in a constant manner. So there is not a way, it's not foreseen that this concentration will decrease in the next decades, unless we do something. Now, this is a problem because the increment of the CO2 and in the atmosphere clearly alterate the atmospheric equilibria. And in turn, this alteration of the atmospheric equilibria led to a sensible increase in the average Earth temperature. Average Earth temperature that is coming out of control, because we have to consider that in comparison with the average global temperature before the second industrial revolution, now the temperature increases of 0.7 degrees C. And if we do nothing to decrease the concentration of CO2 and other greenhouse gases in the atmosphere, it's expected that the temperature will increase up to 6 degrees C by the end of this century. The most pessimistic projection say 6 degrees by 2050. Now, we know what this climate change, this alteration of the atmospheric equilibria is leading to drought, wildfires, uncontrolled meteorological event or rise of the sea level. And these all will lead to suffering of part of the world population, which will have to move from their actual location to place where life could be better. Now, what are we doing? So are we letting things happen, or do we have any control over this happening, over climate change? Well, so what we can say is that from the time of the discovery that climate change was happening, and we were in around the 1950s, not much has been done until the 1990s. 1990s, the community, the states, they started to discuss what could be done, also because where the impact of the climate change was already evident. So what can be done? So the first step were done in 1990s, as I said, and that was through the Kyoto Protocol that opened a period of discussion on policies for stopping the climate change. More recently, one of the most famous meetings has been the Paris one, the COP21, where was signed the Paris Agreement. So we are at 2016. Now, what are aiming this meeting? What are these Paris Agreement or the Kyoto Protocol are aiming at? So they are aiming at stopping the global warming. And in particular, in the Paris Agreement was stated that whatever has to be done to stop the global warming to a level of maximum 2 degrees C, better 1.5 degrees C, over the pre-industrial levels, so before the 1870. So this is not easy for sure, but for achieving such a goal, we have to reach as soon as possible a peak of the global greenhouse gases emitted in the atmosphere. So often we think about greenhouse gases and we think about CO2, or we speak about CO2 equivalent, but in reality, there are many more gases that have a greenhouse effect. So there's not only CO2, there is methane that has a warming power that is 80 times more higher than CO2. There is the sulfur hexafluoride, there is the perfluorocarbons, there are the hydrofluorocarbons, there is the nitrous oxide. So all these gases have to be cut and drastically if we want to achieve the final goal of limiting the greenhouse, the warming effect to a level of 1.5 to degrees C. Now, the Paris agreement signed in 2016 has been a landmark among the climate change meeting or summit, because for the first time, the participating country reached a binding agreement to undertake ambitious effort in fighting the climate change and to adapt to its effect. So we are speaking about not only fighting the climate change, but also to adapt to the consequence of climate change that are already occurring and that will be really difficult to arrest, at least in a short time period. Now, so this agreement, the Paris Agreement, led the participating country to commit to some pledges. So, but how can we monitor the achievement of the goals that were set during the Paris Agreement? Well, this is done in cycles of 5 years through the checking of the so-called national determined contribution. So the national determined contribution are action that the state subscribe to take to reduce their greenhouse gas emission, and action that they will take to build resilience to adapt to the impact of rising temperatures. So each 5 years, there will be a meeting where these goals will be checked and will be adapted in a way that will be more committing more and more to a so-called zero emission policy. Now, I said that in this agreement, many countries came together and agreed together to make some commitment to reduce the greenhouse gas emission, as well as doing something to adapt to the climate changes. Well, not all the countries can act in the same way, and therefore the lead has to be taken from the developed countries that more than others are responsible for the greenhouse gases emission, and that are those that historically caused the most of the damage to our environment. So what is written in the Paris Agreement is that the developing country have to support financially the developing country so that they can afford to take action to reduce the greenhouse gas emission and to fight the effect of the climate change. Moreover, it's always written in the Paris Agreement that the developed country have to establish a technological framework, technological platform, which provide the best technology for all the country, and therefore also the developing country, to fight climate change and to reduce their greenhouse gases emission. However, we have also to keep in mind that not all the countries have the capabilities to plan and execute such demanding policies. So then the developed country have to act on improving the capacity building of this developing country, where by capacity building we intend the process of developing and strengthening the skills and ability that community needs to tackle the climate change. So this is all written in the Paris Agreement. However, in the last 5 years after the Paris Agreement, not all the goals that were planned were achieved. No? So, and we reached the point where this year the Glasgow Climate Pact was signed. So it's something after the Paris Agreement, and this the Climate Pact are being signed by almost 200 countries in the COP26, so the Conference of Parties 26. So this year, last November. So the Glasgow Climate Pact had been signed at the COP26 in Glasgow, as I said, by almost 200 countries. And what was the aim of the Glasgow Climate Pact? The aim was to keep alive the hope of limiting to 1.5 degrees the temperature rise on the global scale. So now, if you look at this thermometer, now we have, it clearly indicates the pre-industrial level that is where we have to go back if it's possible, but is our standard is our 0 point, no? So we have not to go more than 1.5 degrees higher than the pre-industrial average temperature. At the moment we are sitting here, so we are dramatically close to the 1.5 degrees C of the Paris Agreement goal. No, and actually, so if we don't do anything to improve the actual situation, we will exceed the 1.5 level and we will reach 2 or more degrees C of global warming. Of course, it will be much less than the 6 degrees that we will have reached by 2050 if we will have done nothing. So already with the previous agreement, a lot has been done, but not enough. Now, the Glasgow Climate Pact will try to strengthen what has been promised with the Paris Agreement. And to do so, we'll lay on 4 pillars: mitigation, adaptation, finance, and collaboration. Where for mitigation, we consider the reduction of the emission. Adaptation is the helping of the people that are already affected by the climate change. Finance, we mean enabling country to deliver on their climate goals. So climate change, to do something is expensive, and to fight the already present changes, it's even more demanding from the financial point of view. Collaboration is all that we need to achieve the highest possible target in reduction of the global warming. Now, some of the results that were achieved during the Glasgow Climate Pact, during the COP26 as a part of the Glasgow Climate Pact are here listed. Now, for the mitigation, we have that over 90% of the world gross domestic product and around 90% of the global emission are now covered by net zero commitment. So they will be delivered with a net zero emission. 153 countries have put forward new updated emission targets that are the so-called national determined contribution that we saw before. And these are covering around 80% of the world greenhouse gas emission. So we are seeing targets that are extremely ambitious. Now, as a result of this increased cut in the emissions, the United Nations projection have been reduced by 5 billion tons by the year 2030. So that means that the greenhouse gases that were foreseen to be emitted in the atmosphere by the United Nations prior to the Glasgow Climate Pact are 5 billion tons higher than what it will be after the Glasgow Climate Pact. No, so if you have to think 5 billion of tons, so 5 gigatons of greenhouse gas emission is more or less what the United Kingdom produced in 10 years. So it's a quite considerable cut of emissions. No? Moreover, 137 countries committed to halt and reverse forest and land degradation by 2030. And this is really important because one of the countries that committed to this is Brazil. Now, additionally, 28 countries launched a roadmap to protect forests through a global shift to sustainable development and trade of agricultural commodities. That's great. Now, this map here shows how the Glasgow Climate Pact is making a significant contribution to reduce the global warming. So here is the rise to 6 degrees C that I discussed before if nothing will have happened. No? So this is the projection of the temperature over, so clearly here we'll see the annual emission of greenhouse gases emission that will have led over the next 30 years to reaching 4 degrees C of global warming. This is based on the Paris pledges. Now, the Glasgow meeting led to a reduction of the global increase of the temperature of 2 degrees C. But if we consider these together with the net zero policies that have been promised, the goal of 1.5 degrees C of maximum global warming is achievable. So theoretically is a great achievement. Now, we saw that the country committed to reduce the greenhouse gas emission, but we have to consider that a big part of the energy that we use is produced by coal. So what has been done in that direction to reduce the use of coal? Now, that is what I just said. Now, in this graph here, you will see that the power sector is responsible for the 1/4 of the global emission of greenhouse gases. Therefore, what has been promised in the Glasgow Climate Pact is to try to move from the carbon as a source of energy to less harmful sources. And for doing this, 65 countries have now commitment to coal phase out, so to come out of the use of coal as an energy source. For this reason, also a quite large amount of money has been put on the market to support country to power out of the coal. Now, this is always regarding the mitigation of the climate change. So here is you can see a picture that comes from a polluted area of China, but this is the same in many other parts of the world. Don't expect that area like the Padana Valley in Italy sometimes is better than this, or other places in Africa or India or in some area of the United States. So this is quite a reality for many, many people. No? And we have to consider that the road transportation, it's responsible for roughly about 10% of the global greenhouse gas emission. Now, at the COP26, it has been established that by 2030, the country that agreed on it will have to shift the transportation from fossil fuel based to fossil fuel free fuels. No, so we are speaking about a shift from benzene and oil to solutions such as a battery or hydrogen. In this regard, there has been this agreement has been recently signed by companies like General Motors, Jaguar, Fiat, Volvo, Audi, Ford, and Volkswagen, and they have already a strategy for 100% zero-emission vehicle production by 2035. That means that by 2035, this manufacturer will not produce anymore fossil fuel-based vehicle, or at least not fully vehicle running on benzene, diesel, and so on. So this is something that is quite demanding if you consider that just a little bit more than 10 years is left for this transition. Now, what has been promised for the adaptation and in the next few years at the Glasgow Climate Pact. So what we see here is that the climate change is not something that will happen in the future. It's something that is already happening. And the people that are paying the consequence, of course, are those that the least were responsible for the climate change. Now, to shift to a net zero and resilient economies is not something that is cheap and is not easy. So trillion of dollars of investment are necessary, and that cannot be done alone by emerging countries. For that reason, 95 of the largest development countries are trying to now finance, to support the project, to help and support the developing country to achieving targets, and also to try to develop their economy through strategies that don't involve the use of fossil fuel. That is not simple, because fossil fuel is the cheapest and most abundant solution at the moment, and they request technology that is already available on the market. So as you can see here, the International Development Financial Club, that is a club of development banks, put on the market 1.3 trillions, will put 1.3 trillions of dollars between the 2019 and 2025 to help supporting emerging economy to find solution that will impact the least our climate. Now, really important is that to achieve such a goals is that the collaboration. No, so the Glasgow climate at the COP26, over 40 countries that account for more than 70% of the gross domestic product, committed to work together to make clean and sustainable solution the most affordable, accessible, and attractive option in each of the emitting sector before the end of this decade. What does it mean? That means that they will try to make clean power as the most affordable option, or they will try to, like you saw for the commitment of several automotive car manufacturer, making the zero emission vehicles the normal, accessible, and affordable solution. We already know, or at least many of us know, that at the moment the solution of car running on battery or car running on hydrogen is not exactly the cheapest solution. So, you know, you have not everybody can afford to have an electric car, or even less an hydrogen car. Now, then we have to consider that also, for example, the making steels, it's something that is extremely harmful for our climate if we look at the emissions. So something that has been achieved on the Glasgow Climate Pact is that there will be policies that try to make steel, let's see, more environmental friendly. So as a part of this, several pilot projects are running now on making steels based on using hydrogen for melting and for the other process. Moreover, as I said, no, for vehicles, the use of hydrogen beside the use of the batteries is really important. For this reason,
dear Claudio, sorry for interrupting you. We have 5 minutes left to the next speaker. Okay.
Oh, I will be really fast then. So now, the European Climate Pact. So the European Climate Pact was launched in 2019 as a part of the European Green Deal, as a platform to support people to reach a more environmentally friendly society and more sustainable society. Now, the European Climate Pact offers a platform for the people to work together, no matter from which path of life they come, and to together contribute to achieving the goal of a more resilient and green European society. Now, everything is possible when we try to involve everybody in the struggle of achieving a better society, a greener society. For this reason, has been created the role of Climate Pact Ambassador. Climate Pact Ambassador are people like you and me that try to bring the effort of the European community, to communicate the effort of the European community to the people, but moreover to sensibilize people to act in a way that can lead to achieve a more sustainable society. So it's something in between the society and the European community, something that helps achieving the final goal of obtaining a life that is greener and more sustainable. Now, what can we do? What we can say as a conclusion of this presentation? So at the moment, our economy, our lives are based on the use of fossil fuels. These fossil fuels, after burning, are producing harmful greenhouse gases that are leading to an alteration of the climate equilibria that lead to the destruction of our Earth. Now, several meetings and agreements have been reached to try to shift from harmful fossil fuel energy sources to more convenient energy sources. And this appears that will lead to a maximum increment of the temperature rise on Earth of 1.5 degrees C, if really we aim to net zero approaches. But this is only possible if we will work all together as a society to support each other. So I'm sorry for running out of time, and I thank you for the kind attention.
Thank you, Dr. Claudio. Excellent presentation anyway. Thanks a lot.
Welcome.
So I think we have time for only one question, otherwise we run out of time. So, and actually there are quite some interesting ones, but we will go for the Q&A chat posted by an attendee. So I will just read it straight away.
Yeah.
So the attendee says that I learned that most financing to developing nations has gone to projects that reduce emissions rather than adaptation to climate change. Can you speak about climate equity, justice concerns with this voluntary financing agreement? Can you comment on this, please?
Yeah, actually, that is a huge problem, because the amount of money that are necessary for adaptation to the climate change is much higher than the amount of money that is necessary for fighting the climate change. No, so for reducing the amount of greenhouse gases emission, and this it's always a problem when things are done in the rather fast way under time constraints. So it's really likely that now in the next years there will be not an equity, no, in particular in the way the money are shared over the countries. But this should be adjusted in the period, each 5-year period. So practically in the next 2026 now. So they should try to find a better balance that is now. So that is true, it's a problem. And but I believe that this problem will be corrected in the next, let's say, 10 years.
Okay, thank you very much. I agree, it's a very tough question anyway. Yeah. So thanks, Claudio, for this great presentation. So now I will move to the second speaker of the day. It's António Valera. António Valera is a retired professor at the University of Lisbon, who presents interests are models for decarbonization of energy and mobility systems, materials for PV, and air quality in buildings. He graduated in electrical engineering from the IST and obtained the PhD degree from the University of Cambridge. So, Professor Valera, the floor is yours. Thank you very much.
On video. Okay, I hope this right. Let me put this in presentation. Okay, can you see this?
Yes, we can. Thank you.
Okay, very good. Laser pointer. Here, there we are. Okay, well, good afternoon to you all, and thank you, Claudio, for your excellent review of all these problems. And let me put in a talk on which I shall try to demonstrate that there is a simple solution to the total decarbonization of road transport, which simultaneously solves the central problem of power generation, which is imbalance. So we'll see this later on. Right now, I would only ask you to take my talk as a challenge, maybe even as a provocation, and I hope some of you will recognize the disruption potential of our proposals. So let me go into the outline. So we'll start with the context: carbon neutrality in Portugal 2050. I'll use Portugal as an example for obvious reasons. Now, Portuguese government has made it official long-term policy, a roadmap for carbon neutrality by 2050. Let me go straight to one of the most informing or synthesizing graphs in this work. These are emissions by sector in Portugal at the reference year of 2015. This is now, and this is 2050. Now, if you look at this sector here is essentially power generation. This is industry, this is buildings, this is transport, agriculture, and waste. Now, the authors have decided that industry is very difficult to decarbonize. The same with agriculture. Now, buildings and waste is another matter. There is something to be done, but not quite net zero is, well, zero is very difficult. Now, the great real structural changes are decarbonization of power generation and total decarbonization of transport. Now, these are not original ideas. Across the world, all countries are saying, if not exactly, very similar proposals. Why is that, could you ask? Well, simply because we think we can. We think that we have the technology to do this, whereas maybe we do not have enough technology or enough solutions for the other problems. So the focus of my talk will be exactly power system and road transport, Portugal 2050. These two together are responsible for 50% of the emissions. So let's focus on this. And we'll start with an energy matrix, so we know what we're talking about. Well, in the reference year, we have a total electric consumption of 50 terawatt-hour in Portugal, and this was satisfied by, well, evenly about half from fossils, about half from all, well, this is generally renewables, although, of course, in the waste to energy, it's not totally renewable. Now, if we look forward into 2050, I'm proposing, well, I'm inspired by the roadmap, of course, but I'm proposing that we'll almost double electrical energy consumption. This difference in 40 terawatt hours, 20 terawatt hours will come from the general electrification of our economy, but another 20 is specifically coming from mobility, from the decarbonization of mobility. Now, this is from the consumption point of view. Now, from the generation point of view, let's do away completely with fossils. Let's concentrate on this here. Now, hydro is, of course, resource limited, and we have virtually used most of it, so this is not going to change much. Let's say 10 terawatt hour is how much. This is what we have now, this is what we'll have in the future. Biomass, again, is resource limited. There's an increase here, which I don't quite see how, well, okay, I'm using their number, my colleagues from the roadmap. Now, this accounts for less than 20% of the generation needed. So over 80% will be wind and solar. So this is the problem that is going to, that we have to sort out is how are we going to run this future power system? Now, generation is dominated by sun and wind. They are plentiful and cheap. In fact, costs in Portugal are around 4 to 7 cents per kilowatt hour. This should be compared, say, with 11 plus for nuclear or 26 we pay at home. So this is really cheap. So the central issue of the power system isn't anymore the economic and environmental cost of generation, the central problem, the central issue of this future system is system imbalance. Why is this? Well, exactly because of the dominance of solar and wind, which are variable and they are not adaptable to demand. That means, in other words, non-dispatchable. So this is the central issue of the future power system is imbalance. Now let's quantify this problem in Portugal. Let's not just say this, and let's quantify it really. And let's look into 2 weeks in January 1950. So it's cold, so we have quite a lot of demand. Black is demand. This is Monday to Thursday, Saturday, Sunday, Monday to Friday, and again the second week here, finishing here. Now, if we look at generation, these are obviously the solar peaks in brown. Solar peaks are quite narrow because this is winter. We don't have much day, so this is variable, but the sun comes up and sets at the regular time. On the contrary, wind shows this erratic behavior. This is characteristic of wind. And in this week in particular, we have 3 days of very bad, very low wind. Then we have a peak here, which unfortunately occurs in the middle of the night, which is not so useful right now. Then we have a very good wind on Thursday and a good wind on the evening of Sunday and Monday, the next Monday. So it's very erratic. In blue, this is water, the rivers running into dams where we have hydropower stations. And finally, here, this line is waste to energy and biomass production. So to get a sense of what imbalance is, we add all generation. We can see this, but much more effective for our study is to use really an imbalance function. I define the imbalance function as demand minus generation. And this, I remind you that this must be brought to 0 at all times in an electric system. In electric system, demand must equal generation, always. So let's see what shape this takes. And this is imbalance. Now this is what I call raw imbalance. This is just take wind, solar, water, and waste to energy as they come, and don't make any effort for the moment to balance the system. So without any effort to balance, this is the raw imbalance. And let me show you that this is a huge problem. This is a huge, well, okay, we have to zero this. How could we? Well, assume, for instance, that, okay, we have lack of energy, let's buy it. Let's buy it from where? Well, from elsewhere, say from our neighbors. So we'll import this energy through cross-border interconnections. Now, this is the limit of, well, the sum of all capacity interconnections with our neighbors. And you see that this is technically impossible right now, and it is going to be technically impossible in the future, because we'll never, it would cost us a fortune to build cross-border connections with this sort of power capacity. So, but let's suppose that we did away with that technical constraint, and okay, we have unlimited capacity. Let's still consider what happens. Okay, right now we have this huge peak, and we need to buy this energy from our neighbors. Now, what do you think is happening to our neighbors? Why did this happen, this peak here? This peak here happens because the sun has just set. And everybody, well, we are at this winter peak, the evening winter peak, which is very characteristic. Because, well, this is when everybody comes home, switches on heating and so on, TV and whatever else, starts cooking. So we have this peak here and the sun has gone down. Now, we are in dire need of energy. Well, do you think our neighbors will have lots of excess energy? Of course not. They have exactly the same problem. They'll be scraping the bottom, looking for energy for their own needs. So there, if we do manage to buy energy at this time, it will be very, very expensive. Well, maybe we could recover some of that expense by selling extra energy. This is excess energy that we could sell. Well, unfortunately, these peaks here are all solar peaks. Some of these here are wind peaks as well, that we have some wind. But the problem is there's a huge correlation with sun in our country and sun in our neighbors. And there is a huge correlation also of wind. So if we do manage to sell this, probably our neighbors will have the same problem, excess energy. So if we probably will not be able to sell it, and if we sell it, it's going to be close to zero. So this is the real imbalance problem, the central problem to solve. If we were to solve it by buying and selling, we would use a huge fraction of our GNP just to pay for this energy, to be able to switch on the lights anytime. So this is the problem. Let's have a look now we've looked at the electric system. Let's look at road transport. What are the central problems of the future decarbonized road transport? Well, there are lots. Well, in my opinion, traction will be electric. We'll talk a little bit about this later on. What are the problems? Well, Claudio, in his nice presentation, said it. Battery electric vehicles are expensive. Hydrogen-powered ones, even more so. So, another problem, how do we take energy to the traction motors? We use batteries. Is perhaps hydrogen a better solution? What about autonomy, charging times? What about using trolleys? That means overhanging wires to feed while on motion for vehicles, or whatever else. What about the costs for solution? Infrastructures included. Don't forget that infrastructures are important for all this. Now, so the central problems of road transport decarbonization for our future transport are really, I resume this into cost and use. Within use is autonomy, refuel time, infrastructure. So these are the problems that we need to solve in order to have decarbonized transport.
Valera, let me interrupt you just, I'm sorry. Try to be a bit kinder with when you pass to the next slide, because it makes a lot of noise to the attendees. Can you do that, Valera?
Sorry.
Thank you. Thank you very much.
Let me use my mouse instead of my
finger. Exactly.
Maybe,
thank you very much, Valera.
Maybe this is nicer. Okay, so let's go into the core of my talk, the impact of decarbonizing transport in the decarbonized electric system. And I'm already mentioning one particular model that we'll be using, which will be the, whoops, well, this is not working. Sorry, I'll still have to do this, but I'll do it more gently, I hope. So so let's first see what the impact road transport decarbonization will have on the power system. Whatever the solution we need energy, and energy will be from the electric system. So it will weigh on the electric system, decarbonized energy. Let's quantify this impact. So on the energy, if you look at the world average, well, the energy spent on road transport is this. The electric energy consumption is about this. So it's about 130% road transport over energy consumption. If you take Portugal, is 137%, the European Union, 134%, USA, 136%. The odd one out is China. China, because, well, let's not think too much about China, because China is catching up very fast. So road transport is increasing by double digits per year. So next time we know, it will be like all the rest of us. Now, so a good round number is energy consumption by road transport is about 135% of electrical energy consumption. So this would mean that we would have to more than double all electric generation just to satisfy road transport demand. Well, unless maybe we achieve a significant efficiency gain. Well, let us consider efficiency for a moment using a present-day polemic. Well, all of you have heard about the Clean Planet for All European Commission. This is taken from a working document. You know that this was presented in 2019. Well, if you take heavy goods vehicles, these are heavy trucks, in 2050, what are the proposed fuels share to keep heavy trucks rolling? Well, 3/4, the proposal is 3/4 of all energy will come from biofuels and synthetic fuels. Synthetic fuels are fuels that are made out of energy. Now, about 1/8 is still the old fossils, and about 1/8 only battery or battery plus trolleys and hydrogen only. This. Now, sometimes it takes an industrial leader to have the guts to have a strong word about policy. This is Martin Dawn from Daimler. Daimler Mercedes is the world leading producer of trucks. And 2 years ago, he said, Berlin and Brussels should realize that e-fuels for trucks are a bad, expensive bet. Now, why did he say that? Well, one reason is certainly this one. Well, this line here is the total production of renewable energy by Europe, by the European Union. It's 1,000 terawatt-hour. This is 20 times the whole of energy consumption, electrical energy consumption in Portugal. So it's a very large amount. Now, just for heavy trucks in the EU, if we take batteries or batteries plus trolleys, a whole half of all this energy will be necessary to keep them rolling. But if you switch from batteries to hydrogen, not all of it is enough. And if you go for synthetic diesel, not even double of it is enough. So when we are talking about efficiency here, we are not about talking about 10 or 20%. We are talking about 200, 400% difference. So we must be careful when we are making our choices on what the consequences of this are. So we've talked about energy, let's not talk about power. How much power is on wheels now? How much the motors on all our vehicles are worth? Well, this, if you haven't seen this done, this is really amazing. It's 100 times the average power of the national grid. So it's the mechanical power on wheels is 100 times the average power of electricity in our national grid. This is a huge amount. Well, consider that you were to shift away from fossils right now and change all vehicles to, say, battery electric vehicles. Then this would be the nominal power of the batteries on the vehicles. It would be have to be about the same. So think that 10% of these batteries only are connected to the grid. You would have 10 times the average power of the grid on these batteries. This is a huge number on which I would like to call your attention to. Now, another problem connected with refueling on battery vehicles. How does power connection of a diesel refueling hose compare to current EV chargers? Well, you know that, okay, regular chargers are about 10 kilowatts, fast chargers are about 100 kilowatts. What about when you press the trigger in your diesel or gasoline hose? Well, do this as homework. It's 36 megawatts. And if this is a hose, refueling hose for a truck, it would be 100 megawatts. Now, this is higher than the average electric power generated by a large hydro such as Castelo de Bode, which is one of the biggest in Portugal. So every time I refuel my car with diesel, I think I'm putting down the whole output of this huge dam. So time to refuel 1 minute. Okay, for the same autonomy, even with an efficiency gain of about 3 times, which comes with batteries, we would need 2 hours for refuel. Well, 30 minutes should be enough for 200 kilometers. This is what we know is currently done with vehicles, with fast chargers. Now, this is a huge problem for heavy vehicles and shared vehicles with a high rate of use. It's less of a problem for private light vehicles, but of course, the inconvenience of use leads to the choice of hybrids. And that's what we are massively doing. So, conclusion, decarbonized road transport will weigh heavily on the electric system. This way and overall cost depend crucially on the option of mobility model. So let's go back to our main problem on the electric system and see what options for grid balance do we have. Well, to start with, we are fortunate to have reservoirs, for rather large ones, for hydropower. So we can manage water. This is very easy. We can simply shut the valves when we have excess power and open them when we are in need of extra energy. Now, pumping, of course, gives another degree of freedom for this large-scale storage as hydro. Then we have thermal power for waste and biomass power stations. Well, these are thermal power, so you can step down when you need, you can put your foot down on the accelerator. When you need energy, you can take it out when we have excess power. So we can do this easily, of course. Now, then we still have export-import. Of course, we can export-import, but unfortunately, export will be mainly close to zero cost, or curtail, which is switch off the shore. This is zero cost in terms of excess cost. And of course, we can import, unfortunately, at high cost, as we saw, because of this high correlation. Now, we can use hydrogen or batteries or compressed air, whatever else, for storage. So this is another way of doing it. But so let's quantify this in the future decarbonized grid in Portugal 2050. So we are back to the same old graph. This is the raw imbalance. And so we are now going to progressively introduce all system balancing technologies. First, let's introduce water management in hydropower reservoirs without pumping, not considered pumping for the moment, plus thermal power management in waste and biomass generation. Now, if you do this, this is the result. This is really disappointing. Why is this such a small increase in balance? Well, it's not such a small one. It's about 1 to 2 gigawatts that you measure here. But unfortunately, the problem is so huge that this looks disappointing. Now, why is this? Well, because the rivers don't have that much water and because waste and biomass is rather limited. So this is what we can do, and it's not much. Well, let's now introduce water pumping. Well, with water pumping, we do decrease substantially imbalance. Now, this means, to start with, that maybe we'll have in our rivers more water going up and down than the natural flow of rivers. This is what this means. Well, unfortunately, this is still huge. We still have 8 gigawatts of imbalance. We still have a lot of imbalance, much too much to live with this. So, and notice that we have taken all the means that we could. That's hydro, that's except for other means. But okay, let's now add the effect of electric mobility. This is the model we are proposing, the BS model. This means battery swapping model. And let's see the effect. And the effect is this. Once we introduce mobility, problem solved. There's a residual imbalance which is perfectly manageable. Finished with our basic problem. Now, is this a miracle? Well, we'll soon see how this comes about, why this happens. Well, let me state it. It's the result of intelligent model of charging batteries for EVs. So we are assuming that all EVs are battery. They are battery electric vehicles. And instead of plugging the vehicle to the grid, we are battery swapping in service stations. That is, we are swapping low charge batteries for fully charged batteries in service stations. This is the BS model. And let me start by trying to convince you that this is feasible. Well, let me, oops. I have a problem here. I have to switch off. I'm on the laser mode. I don't know how to get out of it, but, okay. No. Okay, well, this is unfortunate because I have a video here, which is, but I cannot go away from this. Let me see.
Is it a YouTube link?
Sorry?
Is it the YouTube link for the video?
I have to use not the laser pointer, but the usual pointer. I don't know how to get out of the laser pointer. Well, actually, I've lost it now. Where is this? Oops.
It seems like the laser is not on anymore. Oh, yeah,
No,
is.
the laser is on, but I would like to get it off. And okay, let me do this. Okay. No, it turns on immediately again. Well, it's unfortunate. I would like to show you this video because it shows what is actually happening. But if I manage to show it later on, I will. So let's go for. So I was going to show you a video of an actual battery swapping station working, a present one now. But so if I can't show you the video, I'll describe it. Okay, let me talk to you about previous battery swapping experiments in Europe and UA. Well, Renault did it. There was this was with an Israeli company. This was tested, namely in Denmark. There was very high client satisfaction. They just went on to stations and shifted their low battery for a charged battery, but this is failed. Why? Well, wrong strategy, wrong time. Single brand, small EV market penetration. So this cannot go right at this time and with this strategy. Now, I have a video with Elon Musk saying, this is the future, this is the best thing that's going to happen. It's about the same time. So he started this company. I think the first battery Tesla stations, swapping stations, were made in 2013, but it closed down in 2016. Why? Lack of adoption of Tesla vehicle owners. The problems, same as above. Small EV market penetration, single brand. So if you're an owner of a Tesla and you have about 200 kilometers autonomy, would you drive 30 kilometers just to shift your battery? Or would you stay at home and use another, perhaps a diesel or gasoline vehicle, a second vehicle that you had at home? The low concentration of vehicles is so low that you have to travel, and so it's not easy to do this. So this was a lack of adoption, and Elon Musk closed down the venture and started shifting on to fast charging instead. Now, this is an example of a local present 2021. This is for shared vehicles, and it's a tiny venture, which I don't think has a huge future, but it underlines the problem of shared vehicles. So our approach to battery swapping, multi-brand. So it's not going to be one brand only. It should be multi-brand, heavy vehicles included, and a time which is now of much higher EV penetration. So let's define better our BS model. So I'm assuming that in the near future, vehicle and battery manufacturers will converge into universal standards for modular batteries. What does this mean? It means that the mechanical dimensions and mounting are standard. Now, capacity, power, voltage, whatever else needs not be fully standardized. It's just putting it in and connecting. That's it. The rest, onboard intelligent power systems will adapt easily. Now, vehicles swap low-charged batteries for charged one at battery swapping stations. Which are these? Well, they are simply the present fuel stations, which will change into electric energy hubs, will evolve into this, each equipped with, say, up to 1,000 standard certified for quality assurance battery charging units and about 3 battery swapping robots with about 1 minute swapping capability. Right now, robots have a 2-minute swapping capability. There's nothing to stop them from going down. Well, 1 minute has been demonstrated, and in the future, this will be quite possible. But even if it's 2 minutes, it's not too bad. And typical grid connection of, say, 5 megawatts to the grid, let's say up to 10 for a large station, down to 1 megawatt for a small swapping station. Ideally, modular batteries would be such that small light vehicles might use 1, a heavy freight vehicle might need 20 modules, all identical in shape, interchangeable. Well, this is not exactly a model requirement. Different types of modular batteries might coexist. And of course, there will be premium, standard, low cost. There could even be a Tesla battery or an Apple battery or whatever else. So these will be certain to appear. Now, the big advantage of the BS model is that it decouples battery refueling from vehicle use. There's no fast charging necessary, and thus grid power management is easily performed to the advantage of both the swapping station operator and the power system. What does this mean? This means that while charging, batteries act as a 100% flexible demand, but are also capable of battery to grid system support. Let me translate what this means in down-to-earth language. Well, I'm the owner of this power station, of this, battery swapping station, and I call the grid operator and say, well, I want 50 megawatts hour for the next 24 hours, but please feel free to feed me whenever is convenient for the grid. I don't care what time we feed them, so long as you give me the energy I want. Oh, by the way, if you have problems with the grid, do come and take the power that you need from my battery swapping station, both for balancing the grid, or even if you have an accident in the grid, a shutdown, a short circuit, do use this for, say, even for frequency regulation or for energy balancing, whatever. Come and take at will. Just give me that energy at the lowest cost. So this will have a huge, as you will see, we have seen the huge impact on the power system. Other major advantages. Well, electrification of long distance transport is very easy. It's obvious how you would do it. Acceleration of transport decarbonization would be huge because vehicle use is as simple as present. You just go to a station, recharge, and switch batteries and carry on. Finally, it will be the lowest cost model. Now, these are details on what to do, how batteries, this is quite stringent on the batteries. They are always, there's no fast charging, it's always slow charging, and it's flexible demand, and this battery to grid capability is very, very limited to, well, this is to low rates. This is a 10-hour discharge rate, and to very low depth of discharge, say 10% maximum, and limited only to batteries that are not degraded by this. So it's quite stringent on the care about battery non-degradation by this procedure. So let's look deeper into the effects of this flexible load and battery to grid in our system. Now let's consider only 1 week instead of the whole 2 weeks, so we have a little more detail. Now, this is the old raw imbalance. This is what, when you introduce waste to energy and dams, this is with pumping. And now let's introduce only flexible demand and not battery to grid. And what you get is this. So most of the effect is actually flexible demand. It's not battery to grid. So the technical problem of grid balance is solved. This is absolutely easy. It's not a big problem, a huge problem to sort out these small peaks. Now, if you add battery to grid capability, that tiny bit of, you get this. Now, why do you have these flat lines? That's because our software simply minimizes imbalance in 24-hour time frames. And here, what this is telling you by being a straight line is that we have extra capacity, unused energy and power capacity in this battery to grid. What this means is we can use this extra capacity to buy zero here and to buy the energy that we do need. This is the same energy that we are buying here or here. The area is the same, but we can simply import zero here and import perhaps here and here when prices will be much more amenable. Now, this is not a huge technical problem, but it is a huge economic advantage. You can buy and sell energy anytime you want, rather than when you have a rope around your neck here. Now, there's another huge advantage that I told you about, which is grid services. You can, for instance, with this, you can do even give resilience to the net, to the grid. You can even do compensate. Well, you can do, for instance, synthetic inertia for the future grid. You don't have these big rotors for thermal machines, but you can synthesize it using this power to stabilize the grid in case of accidents and so on. So let's leave January and go to May, just so you see, well, this is a week with a huge excess of energy. This is again raw imbalance. This is again when you put in water reservoirs, so dams, hydropower and whatever. This is when you do pumping. This is when you do flexible energy. And this is when you put in this little bit of battery to grid. And again, you don't have to export in the solar peak. You can export here or here rather than here. So this is what it is meaning. Now, to convince you, let me show you a whole year. Well, this is our week in May when you have all this excess. This is our week in January. They are actually chosen as the worst weeks of the year. And in dark blue is just flexible load. In red, this is with battery to grid. And you see that just the technical point of balancing the grid is totally done simply by flexible load. You don't need really the battery to grid, but this, of course, further improves the impact of mobility on the grid. So suddenly the system is essentially balanced. The grid becomes much more resilient. Electrification of heavy vehicles is easily achieved. Huge acceleration of transport electrification occurs. Sorry, I'm getting enthusiastic and thumping my finger again. And no need to throw away about 10% of generated energy, curtailment, export at bad conditions, or use it to produce hydrogen and synthetic fuels sold at almost zero cost. So no more capital drain from the power system. And so electric energy will be less expensive. So our conclusion, grid imbalance has a simple solution in sight. It's a soluble problem with little intrinsic costs. So implications, let me use frequent words. Let's stop using the expression energy excess. It will have the capacity to soak any excess in energy. Stop assuming curtailment is inevitable. Stop counting on energy sold at nearly zero. The beauty of the BS model, no waste, fantastic grid balance, and much of this is paid for by road transport. Conclusion. The two great structural changes in the energy system in 2050, the dominance of non-dispatchable renewables and the electric mobility, taken together are the solution to the total decarbonization of all road transport and the stability of the decarbonized power system. So these things just click together and you have this fantastic result. Now let's go on to fourth chapter, transport alternative routes. So we have considered plug-in, all vehicles are electric plug-in, catenaries, that is heavy vehicles are fed from overhead wires along main routes and have batteries for the rest. Light vehicles are plug-in, hydrogen, heavy vehicles run on hydrogen, light vehicles are plug-in, and finally, battery swapping, all vehicles are swapping batteries. Now, if you compare these are our old 2 weeks in January. And this is our battery swapping, what is happening, and these are the other models. Well, in yellow is the old pumps, so all classical means of balancing the grid. This is plug-in. Now, plug-in is really disappointing. We have put in vehicle-to-grid, modulation of charging, whatever else, and still we only manage for this very disappointing increase in grid balance. Well, this is really the reason why we have all this power available, we have all this energy available. Why can't we do better than this? This is why we decided the only way is to decouple vehicle use from vehicle charge. And once you do this, you get this. This is the real trick, is to decouple vehicle use from refuel. Now, if you use hydrogen, you have quite a better effect, but still much worse than this. Well, to be fair, of course, you can, with hydrogen, go down to and balance the grid and all that. The main point is at what cost? So again, those 2 weeks in May, when you have to show you this imbalance, these are 2 weeks in August, which are most of the weeks of the year will look more like this than those two others. And this is a whole year. So green is hydrogen, gray is plug-in, and this is battery swapping. So I may have convinced you that battery swapping is fine for the grid. Now let's look. Well, this will have no future if all stakeholders don't gain something from it. So those results are published. These are not published yet. These are preliminary results on which we are working on costs now more seriously on the transport side. Now, let's put ourselves on the perspective of a 40-ton truck. This is the result of our calculations of the different models. This is ICE, that's diesel, a diesel truck. This is battery swapping, plug-in, and H2. Now, what you find from these calculations is that if I'm the owner of a truck and I want to buy a new one, it's a no-brainer. I'll buy a battery swapping one immediately. Why? Well, it's cost is lower already than a diesel truck. Why? Because you don't buy the batteries. This is batteries, this is the rest of the vehicle. A vehicle without batteries is already cheap. But then, of course, you have to pay for all the infrastructure, the batteries and the battery swapping infrastructure and all that. But once you do the calculation, this turns out to be about the same as in plug-in. So you have an advantage here. This is the sum of all. So this is fuel, maintenance, and infrastructure costs. Once you put all these in that you have to pay for, you have this. This is much lower than hydrogen. I'm looking for hydrogen, well, in the future. This is in, say, 10, 15 years' time, and the hydrogen trucks are not very expensive anymore. But this is much more expensive than this. Well, so there is an obvious advantage, and I would definitely buy a battery swapping truck. Now, if you take a government perspective, if you look at the total transport sector, road transport sector, plus the power sector together. So here we are putting vehicle acquisition, repair, maintenance, energy infrastructures. And in the power sector, we are putting in additional generation necessary, cost of system balancing, all this together, and we estimate the result. Now, once you do this, the lowest cost is indeed battery swapping, 0. Now, for plug-in, it would cost 2.6 thousand million euros more. Well, let me put this for a more international perspective as a fraction of GNP. This would cost us 1% GNP more plug-in. Hydrogen would cost 3% more in GNP. Now, ICE, if we stick to what is the cost without tax for diesel, which is this, even that it's almost a par. But if we take this as the cost of environmental damage and whatever else, its policy to put in a cost like this, then it's 2% more. So BS is the...
Valera, sorry for interrupting.
Yes.
I think we have to speed up because we have the next speaker already online. So maybe we have 5 minutes more and we have to close up.
Okay.
Sorry, Valera. Thank you very much.
Let me accelerate. So I'm skipping off. These are 2 slides on which I'm comparing plug-in and battery swapping. And let's go straight to, will this become reality? Well, it's unfortunate that I didn't show because this is this was to show you that it exists already. But let me talk to you about signs that this is going to happen. Well, Scania is a puzzling example because it's a company that one of the companies that most invested in hydrogen technology. It's one of the few companies with a commercial operation with H2 trucks with clients. It sold several thousand vehicles, and this year decided to abandon hydrogen and switch to battery trucks. Well, so this is okay, but let's go on to other signs. Battery swapping in vehicles. This is tiny on energy scale, but it's interesting. The most interesting, well, okay, this is in Taiwan, this is very popular. There are over 2,000 BSEs battery swapping. They look like this. So you just stop your scooter, you take a new battery, put it in and go off. Now, but most significantly, this year, about 2 or 3 months ago, Honda, KTM, Piaggio, and Yamaha, these are Oriental and European companies for scooters and motorbikes, they have signed a swappable battery consortium. So this is a multi-brand, so they are going in the right direction. That's what I mean to say. They are going to share batteries for their 2 wheels. Now, the actual action is in China now. Now, let me just mention that Xi Jinping hasn't mentioned battery swapping, but Premier Li Kenqiang is mentioning battery swapping together with hydrogen and charging and plug-in. So they are betting on all three models and see what comes out of it. So right now in China, there are 6 companies doing battery swapping. Unfortunately, they are single brand for the moment. NIO, I think, has the best technology. Well, that's my opinion, of course. And but let me talk about NIO. NIO started this 3 years ago with installation of 8 battery swapping stations along the Beijing-Shanghai route. And right now, they are on the way to achieve 500 battery swapping stations. Right now, they have already done 4 million swaps, and they have a new BSS announced with 1 megawatt capability and so on. This is their network of battery swapping in China already. And they are offering battery swapping as a service. They sell the EV without battery payment, and they have, with a small fee, they have N free swaps per month available. So they are going into the right direction. Now, on batteries, they are currently producing 100 kilowatt batteries and selling it at $88 per kilowatt hour. Guys from batteries, look at that. Announced a new battery, 150 kilowatt hours, all solid state, silicon carbide anode, that will make their vehicles reach 1,000 kilometers. Notice that this is the same battery pack that 3 years ago was less than half this. So the same battery pack is simply increasing capacity, because as battery technology is evolving, the same vehicle that I bought 3 years ago now has much more capacity and autonomy. Now, Tesla is promising very similar things, of course. Now, conclusions. Let me repeat and stress this. The dominant of non-dispatchable renewables together with electric mobility, taken together, they are the solution to total decarbonization of road transport and stability of the future power system. Then the outcomes, looking at the power system. We have a stable, carbon neutral, reliable grid. We have lowest costs, electrical energy will be cheap. And the beauty of the S model, again, no waste, no ruinous import-export, fantastic grid balance and service, and much of which is paid for by road transport. The batteries are not paid for or owned by the electrical system. They belong to the road transport, and I paid by it. Now, on road transport,
I think we have to close. I think we have to close.
Two slides. Vehicle use becomes as it is today. No emissions. BS vehicles will be cheaper than present diesel. BS maintenance and refuels is cheaper. Electric mobility adoption accelerates. Now, let me see just a quick look at industry. Electric energy becomes cheaper than gas, than hydrogen gas that's produced from electricity. Then industry will adapt, substitute fossil fuel burning for electric heating. Think of ceramics, glass, energy guzzlers. So if you don't burn, you don't have need for huge fluxes of air for oxygen. For 1 cubic meter for natural gas, you need 10 cubic meters of air. So if you don't need that, then industry starts using processed gases in a closed loop. What does this mean? No more spewing chimneys, no more emissions of CO2 and NOx, no more emissions of particles and other pollutants. So conclusion, BS path is the fastest, cheapest, most socially acceptable, the least environmental impact, and a direct reduction of 50% of emissions, and an indirect reduction via electricity cost, grid stability in the industry, buildings, and so on. So, which research? Batteries, batteries, batteries. intelligent electrical management systems regulation. Our present regulation will not do. So we live extraordinary moment. We have presented an ignored, unexplored path, and I would like to have your company while studying this unexplored path. And thank you, and I hope you had understood my provocations. Thank you.
Thank you very much, Valera, and thanks for sharing all your ideas, because there are many there. But unfortunately, we don't have time for questions right now, but we will address them in the end. But I can promise that you have quite a lot of things to answer later on. So now I introduce the next speaker. It's a pleasure to have Professor Di Ciaso here with us. Professor Di Ciaso is the Dean of LBJ School of Public Affairs at the University of Texas at Austin. He's a distinguished scholar focusing on clean technology policies, policy designed to enhance environmental equity, methods for valuing changes, environment quality, and performance of public agencies. He has served as a policy advisor to international organizations such as the World Bank, the Asian Development Bank, and the United Nations, and is advisor to federal agencies such as the National Science Foundation, the Department of Energy, Department of Transportation, and the Environment Protection Agency. Di Ciaso earned a doctorate in urban planning from Harvard University and a master's in development economics from Oxford University. So again, it's a great pleasure to have you here with us. And please, the floor is yours. And sorry for the delay.
Not at all. Thank you so much for having me. It's my pleasure to join you and to follow Antonio's presentation on batteries. What I thought I would do is give you an overview of how here in the US, we are trying to implement the aspirations or the inspiration behind the Green New Deal at the state level, and to talk a little bit about some of the state leadership and California in particular, to give you a sense of where the frontier is, at least in the US, in this space. And so let me start off by, and let me also say, unlike many of you who are experts in engineering and the development of new clean technologies, what I'm going to talk about are the policy drivers that we can adopt and that the US is thinking about adopting that would incentivize the purchase of these technologies and allow them to scale. And you know, the story in the US as it is around the world, I think, is one in which certain states have taken a leadership role in incentivizing the adoption of these technologies. And I just want to sort of share with you where we are today. And again, I'm going to focus mostly on California. And I'm going to talk about the electricity sector, and then I'm going to talk about the transportation sector and the policies that have been most pivotal there, so that we can think about you know, making these choices available in other countries around the world, and sort of understanding kind of what the trade-offs between cost and the scale of adoption has been. So let me start off with the electricity sector in California, and let me just start off with the observation that there are now, I think the number is as high as 78 communities in California that are 100% renewable energy. And that renewable energy includes hydropower and geothermal, in addition to wind and solar. And if you were to take the average amount of renewable energy consumed across the state of California today is at about 63 to 64% renewable energy consumed. And so one of the questions that one might ask is, how has that relatively high level of renewable energy consumption been made possible? And I want to highlight the important role of clean energy standards in accomplishing that goal. There are the state of California has consistently ratcheted up the clean energy standards requiring more and more renewable energy be adopted by and purchased by the three major investor-owned utilities and then the two major public utilities in the state. So it has the advantage of really only having five really critical utilities. And so the clean energy standards applied to those suppliers of electricity have been very effective over time in encouraging them to increase their adoption. And one of the great things about this from a carbon perspective is it has made the need for local energy efficiency upgrades to buildings less relevant, because the electricity consumed by those buildings is much, much, much cleaner than it was 20 years ago. And those energy efficiency and weatherization efforts are much more expensive. They're much more decentralized. You know, you're targeting hundreds of thousands of buildings. And it's what we've learned is it's much more efficient to move upstream to the five utilities and change the carbon content of their power mix as a way of reducing GHG emissions than it is to try and retrofit, 4 million buildings so that they become incrementally more energy efficient. It's not to say that energy efficiency isn't important still. One of the things I would share with you is that we've, in California, because we were an early mover, the way we got to that mid 60% renewables was by requiring those utilities to adopt more wind and solar, which was expensive. And so our electricity prices, run from the high US teens to 30 or even sometimes 40 cents a kilowatt hour. So much more expensive than the rest of the countries right now. And so you might want to engage in energy conservation, energy efficiency investments just to save money. But the beautiful thing is you don't need to do it as much as you needed to before to accomplish the greenhouse gas emissions. The other thing that I'll say in terms of the next generation is that California is shifting away from clean energy standards per se that focus on renewable energy content of purchased power. And they're moving towards a new accounting system that focuses explicitly on carbon and the carbon content of the power mix. And this framework is going to require, I think, many years of implementation and phasing in. We tend to think about renewable energy and carbon content as sort of synonymous, but in fact, the way that electricity markets work, they're not, because there's a lot of unspecified power that's purchased, mostly from natural gas in the western part of the US, that has quite a big carbon footprint relative to renewables that's currently not being kind of reflected. So that new carbon accounting framework, which the California Energy Commission is formulating currently, I think will set a new standard in the US for how we think about the quality of and the carbon friendliness of electricity purchased in the future and both produced and consumed in the future. So I think in terms of the frontier, even though we've gotten to mid 60s in terms of renewable energy, the state of California has realized that it needs to move away from renewable energy as the metric and move towards carbon content, just to reflect the realities of the wholesale power market in the way that the balancing goes on. If we really want to measure the carbon implications of the energy consumed, we have to develop a framework that accounts more explicitly for the carbon content and the unspecified power that's being produced within those markets. So the other thing that I want to shift now away from electricity and talk a little bit, and let me just point out that one of the hopes and expectations is that in California, they can bring the cost of solar down even further. Right now, it's at about 1.5 to 2.5 cents a kilowatt hour. And that is true. And I just want to point out that kind of large scale renewable energy source is much cheaper than rooftop solar. And so there's this growing tension, and in fact is undercutting the cost of natural gas and beginning to undercut the cost of coal and becoming quite competitive with those two fuel sources. And again, it may be disincentivizing the need for local distributed solar as a primary strategy for supplying clean energy. However, the wildfires and issues around grid reliability in particular, as they interact with wildfires, have continued to make distributed solar and wind, but mostly solar, attractive from a resiliency perspective. And the focus on microgrids is something that is increasingly interesting in California. We haven't figured out how to do microgrids in a way that's very effective, but there's a lot of institutional interest in distributed renewables in the context of microgrids as a way of sectionalizing the grid and making it more resilient longer term. So let me just say a few things about the transportation sector. So again, in California, there are two primary policies that have driven the electrification of the transportation sector. One is a policy that probably many of you have not heard of, called the Low Carbon Fuel Standard. And that is a regulation that ratchets down the average carbon content of all fuels sold by a fuel wholesaler over time. And the goal, much like the Clean Energy Standard, is to move towards the top of the supply chain for transportation fuels and begin to require that those companies decarbonize, on average, the fuel sources that they sell. So you can think about it as almost a content requirement standard that is dropping over time. And what that has done in practice is it's created credits for clean renewable energy related transportation fuels like electricity, and it began to penalize gas and diesel production and sales. So the low carbon fuel standard is one strategy that they've employed, and it's changed the kind of the relative prices and the profitability of fuel production for the transportation sector. The other strategy is the strategy we're all familiar with, which is providing rebates and incentives for the purchase of both electric vehicles, light duty, medium duty, and heavy duty, as well as charging infrastructure. And the outcome of this is that, at least in California, and again, I'm using it as sort of an indication of where we are in the country in terms of the frontier on these Green New Deal policies, is about, and it varies from month to month, but somewhere between 9 and 11% of all new vehicles sold in California now are electric vehicles. I want to point out that that is a higher percentage than California has ever experienced in terms of hybrid vehicle sales. So hybrids kind of peaked at about 8%, 8.5%. And so electric vehicles have now surpassed hybrids in California in terms of the market share. And of course, I think everyone on the call recognizes that the automakers have now become more supportive and have made corporate policy changes to commit to providing a wider range of vehicles to the market, which is going to, of course, be transformative, I think, especially in places like California. And California's focus really has shifted away from light duty passenger vehicles towards medium duty and heavy duty vehicles, which make up most of the air pollution contributions are coming from the heavy duty and medium duty vehicles now. And so a lot of the new policy development is, how do we incentivize drayage trucks, heavy duty vehicles, the explosion of parcel delivery efforts, and how do we make those trucks electric? And so there are cities that have adopted zero emission zones so that you can only enter, as a commercial vehicle, you can only enter the zone if you're delivering the vehicle, if you're delivering in a fully electric vehicle, right? And so we're starting to see local governments try and create these zero emission zones as experiments. And we'll see how all of that goes. The last thing I want to talk about is equity, energy and equity. Especially on the electricity side of things, our rates are quite high. And as we forecast going from 60% renewable to 100% renewable, we are now able to kind of estimate what the cost for consumers is going to be. And as we do that, one of the things that we have done for both electricity and the transportation sector is recognize that these high costs per kilowatt hour are most regressive and therefore impacting moderate and low income residents and households and moderate and low income drivers. And so the state of California has really begun to focus on how do we design policies that mitigate the effects of these regressive price increases associated with moving towards 100% carbon-free electricity and 100% electrification in the transportation sector. And we're just beginning on this sort of journey. Some of the more obvious things that have happened have been to have low-income rate assistance programs developed. There have been some legal challenges at the state level to doing this, but low-income rate assistance programs that allow lower-income households to get discounts of 20, 30, 35% on their electricity bill has been one strategy. Readjusting the rate designs, not to have them means tested, but to be volumetric has been another strategy that's been explored. On the transportation side, providing incentives for used vehicles has been another strategy. I think, to be honest with you, from a research perspective, though, none of the strategies that we're working with on the transportation side, in my view, are very effective currently. Certainly those rebates to used vehicles, it's very unclear that they're going to be effective in incentivizing adoption of the used vehicles in the ways that we hope them to do. And certainly it's unclear that they're reducing local air pollution and GHG emissions currently. And I'm happy to talk about that in Q&A. But I think the equity front, now that we, as within the state of California, can see kind of what it's going to actually cost us to get to 100%, we can see the finish line, and we're worried about who's going to pay for the cost of getting us there, and whether there are very significant disparate impacts across groups, and beginning to think about crafting policy strategies that get us there. I will say the one bright point in the transportation electrification story has been municipal buses. It turns out that they're remarkably easy, as you all the engineers in the audience know, to electrify, and I fully expect that to be one of the implementation successes. So I think with that, I will pause and see if there are any questions.
Dear Professor Dichasa, thanks very much. Great talk and great ideas on the decarbonization of California. I don't see any question in the Q&A chat, but I have actually my own, and there are some. If you we have just time for one, I think, and then we will move on to the next speaker. I know that California has one of the highest electricity prices in US. And I know that actually Texas has one of the lowest. What's the trick here? Why is it so different between these two different states?
Yeah. Well, it's a great question, Guilherme. And I think the first answer is that, you know, California in the 1970s and 80s began to increase the regulatory cost of electricity producers and push them away from coal and towards natural gas for air pollution reasons, right? I mean, we had tremendously bad air pollution. And so in addition to trying to reduce emissions from the transportation sector, we increased the emission standards for natural gas and have basically pushed all the coal-fired generation out of the state. That drove up prices. And then the other thing that has happened is as we started to address greenhouse gas emissions, because we were an early adopter and we forced our utilities to adopt renewable energy, you know, starting in 2008, 2009, 2010, they were signing contracts when the cost of renewable energy, you know, was 18 cents, 20 cents a kilowatt hour, right? Today, they are signing contracts for 1.8 cents a kilowatt hour. And so there's a legacy cost effect there. If Texas were to get to 60% renewables today, they would be able to do so signing power contracts at much, much lower cost than California did. So the good news is those that have waited now have, and this is the good news for the Green New Deal in the US more broadly, the conversation 20 years ago or even 10 years ago about the Green New Deal would have required a much higher price tag to accomplish these goals than are required today to meet the same goal. So it's much cheaper to make progress on carbon reductions today than it was before. And that's the biggest difference. I mean, you know, I don't know, I should know the exact amount of renewable energy that Texas consumes on average, but I'm going to guess that that's less than 15%. And California is in mid 60s. And so that's the biggest kind of explanation for the cost difference as well. Yeah, I think I'll stop there.
Yeah, great answer. Actually, I was very curious about that because they are actually so much different, and yeah, I was curious to know that. Thanks very much for answering. Maybe we have a time for just a very quick question from Pedro Benedito. So his question is: can you elaborate a bit more on the challenges you mentioned on the microgrids phase? Are they technical, economical, or regulatory?
Yeah, that's a great question. The answer is they're all three, right? I mean, if you're going to situate a microgrid, you have to think about the grid architecture and how you can sectionalize it. And then once you've sectionalized it, which is going to be based on the historical grid design, one of the big questions in California they're trying to figure out is who pays for the additional microgrid functionality. And again, we get back to equity questions because you could socialize the cost of microgrids, but the benefits are highly localized typically. And so the state is at this moment trying to think about, well, if the benefits are so localized and the costs are pretty high right now, these are new technologies that we haven't brought the cost down as much as we need to. So, you know, the estimates that I have seen that are credible is that to be in a microgrid, you're more likely to have to pay twice as much as you normally would. And one of the questions that still remains to be answered is, and for how long do you get to enjoy those resiliency benefits? Is it for 72 hours? Is it for 10 days? You know, how long can that microgrid function? And we're beginning to pilot. I think there are 32 microgrid pilots right now in the state of California. Most of them are being evaluated purely on their technical performance metrics. Most of them don't have the capacity to sectionalize right now. So they're beginning to experiment with this. And then there is the question of who's going to pay, how do you finance them as an ongoing business model? I think those are important questions that we don't know the answer to yet.
Yeah, I completely agree. There is always the social impact there, and maybe I will raise a question related to that in the roundtable session. But now, thanks very much, Professor Dichaz. I hope you can stay with us for the roundtable session. Now we move to last speaker of the day. We have João Ribao. João Ribao is a national representative and contact point for the Horizon Europe at ANI, focusing on industry, digital, and European Innovation Council. Ribao has a PhD in mechanical engineering from the Technical University of Lisbon and has previous experience as a head of R&D unit at ISQ and as a researcher. So please, João Ribao, the floor is now yours. Thank you very much for being with us.
Well, thank you. First of all, good morning and afternoon. I hope you see the screen. If not, please just say something to me.
Yeah, we can see that. We can see that. Thanks.
Excellent. So let's start. First of all, I bring you here today somehow an understanding of what is the funding opportunities in Horizon Europe. Obviously, the advantages of participating in such funding program and how to get funding from this kind of programs, and obviously some specific opportunities, research areas, thematic opportunities, and how to get ready for them. Obviously, this kind of theme is known for some of you and others don't. But I wish to somehow remember and reinforce this kind of knowledge or get your curiosity and generate doubt, because for which these doubts we are here to help. Let's really start this. So what is the EU budget for the future? We have a lot of EU funding programs. Some of these programs are well known in national institutions. Some of it don't. Horizon Europe is just one of the programs, mostly focused on R&D projects, and we have here 95 billion euros to support these kinds of budgets. So it's a lot of funding for almost every area of research and innovation that we are willing to submit our project proposals and hopefully be successful. The Horizon Europe itself is divided mostly in three great pillars. Pillar number one is focused on excellent science, world-class science, developing new technologies, new science, skills and jobs and well-being in the science sector. We can see here also the research infrastructures along with Marie Curie and ERC grants. Then in pillar two, we have financing for specific areas. These areas are divided in what we call clusters. So we have here top-down opportunities to develop breakthrough solutions, obviously all or most of all in multidisciplinary collaborative projects. This is obviously useful to test, demonstrate, and scale up promising solutions in, for instance, health, which is in cluster one, culture, creativity, and inclusive society in cluster two. Then we have civil security in cluster three. We have in cluster four the digital industry and space calls, and then in cluster five climate, energy, and mobility, and in cluster six food, bioeconomy, natural resources, agriculture, and environment. So if you have a project dealing with these areas, this is a good starting to look for these calls in here in pillar two. Then in pillar three, it is common to say it is a pillar focused on enterprises, more specifically in SMEs. It is not entirely true. We have, for instance, one instrument which is the EIC Pathfinder, the previous Future Emerging Technologies, which deals with supporting R&D projects in low TRL levels for 1 to 4. So the idea and the research idea to the proof of concept. And yes, we have other kinds of instruments in the European Innovation Council and in EIT, European Institute of Innovation Technology, that are more focused to building a startup, a scale-up, starting to engage the business plans and putting things more close to the market, so the innovation itself. But for today, I will be focusing mostly on Pillar 2, but obviously we can later discuss some ideas on the other pillars, but Pillar 2 is where the large share of the money in the Horizon Europe is mostly. So let's get into Pillar 2 and see what are the advantages and topics inside it. So first of all, the advantages of participating in this kind of programs such as Horizon Europe. Well, this is important to talk because obviously in national terms there are several other funding opportunities. So it is also good to talk about the advantages in specific getting into a collaborative project that sometimes scares the researchers in the industry to share results and to share knowledge. Well, first of all, one thing to say is that any company can participate, any institution, and from any country can participate in projects in the Horizon Europe. Perhaps not all can be eligible for funding, but that's another thing. But anyone can be a partner in an European project. And the advantage here to have a collaborative project, which is the key here, is somehow to achieve something that is too big to do alone, to get and gain more skills and knowledge, expertise that our company or our research institution don't have, to gain access to more science and technology done in another part of the world, obviously, collaborating across value chains, the business chains, overall also boost deployment of the solutions and innovations that our company or our research institute is producing. And the best way to do it is in a collaborative project. Obviously, there are gains and pains in that, but there are much more advantages in doing that than disadvantages. Moreover, participating in Horizon program obviously will bring you some leverage of results, not only as a collaborative project itself, which also deals with activities of building the results exploitation and dissemination, but there are several platforms and activities in the Horizon Europe that will boost our results deployment from results platforms, innovation data platforms, to the EIC or EIT business acceleration program. So it is also a good thing to get a look at. There are multiple kinds of funding instruments in the Horizon Europe, from the basic research to scaling up and penetrating our solution into the market. Obviously, it is also important to say that we have research and innovation actions which deal with the low maturity research and innovation, which usually offers 100% of funding rate, which is really good for all the institutions. And then the innovation calls, which deal with penetration to market, demonstration tests, more close to real life. And in this case, the financing rate for companies are usually a little bit lower, but for research institutions in academia, generally it maintains at 100%. So lots of instruments and the different kinds of financing terms. The business and science collaboration is something that I want to mention here also, because it is very important to understand that the collaborative project, mostly it has gains in this kind of collaboration. It brings to the research institution, which creates the ideas, the more creative part of the project. It has discoveries, advanced scientific breakthroughs, but it brings to these kind of institutions the idea of what is really needed in society, how is the market, how will be the acceptance and the viability of this thing that we are researching and developing. And the synergies between the business and the science is pretty useful, not only for sake of the project itself, that will be more robust, but also for sake of actually generating knowledge that will be of added value. So don't be afraid of making collaborative projects. This is the core of a good development. For instance, Silicon Valley is a dramatic example of what is the rich collaboration between the research in academia and the business itself. And this is just one kind of example that obviously should be pursued in making projects, for instance. Now, okay, but where is the funding for my project? What is this, the Horizon Europe? So talking about Pillar 2, which we have the cluster for thematic projects. These thematic clusters can be seen as sub-chapters of the great book of the Horizon to Europe. So we have lots and lots of topics in each thematic area or cluster. For instance, each cluster can have from 200 to 500 pages full of different topics. May be confused, but it means that there is also an opportunity for you, for sure. What kind of flux does have this topic, which is top-down? Well, obviously it has a title, and then we have a table here expressing some of the properties of this topic. For instance, the budget that it is expected, 3 to 5 million in this case. Then we have the kind of project that it is expected, research and innovation action, dealing with TRL 3 to 5. This means that we are right in the core of research and development, from the basic research to the proof of concept and or prototyping. And here they want us to develop, that our project develops, for instance, lightweight materials for energy efficiency, efficient structures. Okay, how to read this topic? First of all the topics have two main areas: expected outcomes and scope. In the expected outcomes, we will find what they really want, what are the desired effects of our project in the medium term, such as uptake, the deployment of the project results in direct target groups. In this case, here we have also that they want, for instance, reduced costs, less impact in CO2 in what concerns life cycle approach, more biomaterials in this kind of advanced lightweight materials solutions. And then we have the scope, which describes the area of research, the methods or approaches that they are expected that we take, somehow also the application of our solutions. In this case, in the scope, we see here, for instance, that the application should be used above 300 degrees. That we have also a concern on the environmental impact and the well-being of citizens. That, for instance, we should develop new chemistry. So these are all things that we must respond when we are submitting our project. Very different from the open call or a bottom-up approach. So inside all of these clusters, all of these thematic areas, we will see lots and lots of these kind of opportunities for many tastes. In what concerns budget, we can have from 2 million to, for instance, 30 million. We can have very low TRLs, or we can have projects that want us to deliver some solution very near, very close to the market. So we should dig into this depending on our interest in our research results, because for sure there is a topic that can grant you some funds for your research, development, or innovation stage. So let's see some topic examples just to see what kind of funding can we get for which kind of project. We see there lightweight materials for energy structures, but we can have also membranes for gas separation, advanced materials modeling, characterization, advanced characterization methodologies to assess risk and safety in nanomaterials. Obviously, semiconductors and nanoelectronic components are all very important topics that will appear in this work program and in the next ones in 23 and 24. Here we can have some examples of 2D materials for advanced electronics and sensors. Also 2D materials-based device for energy storage and harvesting, biomedical applications, composites, coatings, foams, and specific topics for graphene-based projects. Quantum technologies, we have specific topics completely focused on quantum technologies on the software and on the hardware side. Artificial photosynthesis, novel thin film technologies with high efficiencies, and battery topics are also most of the topics that we can see here related with this thematic area, and many other just miscellaneous example here: valorization of CO2 streams, circular and low emission value chains through digital solutions. Obviously, the circular economy is well present, for instance, in recycling photovoltaic panels, and thermal energy storage solutions for industry or other sectors can also be found in Horizon Europe. So why this kind of topics? Why do we have 6 clusters? Why do we have these topics dealing that they want us to submit projects dealing with these kind of things? Obviously, there are lots of European strategy and initiatives that lead this pathway, but when we write our projects, we must be completely aligned with these kind of strategies. For instance, Green Deal, the chemical strategy for sustainability, Industry 5.0, which mixed a little bit of Industry 5.0 on the technological side, and then get together the sustainability, the human-centric approach, and also the resilience of the enterprises itself, and many other initiatives, from the digital implementation, from the UN Sustainable Goals to the climate Pact. Just to finish, because I'm in my time, just passing through some of specific initiatives. So the earliest ones are a little bit general. We have also initiatives completely focused on graphene, another one on quantum. Then on batteries, we have partnerships that will support the roadmaps and the future research on batteries. Process for planets is completely focused, for instance, in the process industry. photonics, and there are a lot, many other. For instance, key digital technologies, a lot focus on micro and nano electronics, but there are a lot of initiatives and a lot of other partnerships that can be useful for our project depending on your application. Now, just to wrap up, assuming that you may be curious or convinced how easy and how hard it is to submit a proposal to Horizon Europe, well, first of all, get your ambitious idea, your innovative idea, get the concept straight, and then obviously look at a project call as I indicated here. How can you see this project calls? You just go to the funding and tender portal, put here the program that you want to search. Remember the chapters, the sub-chapters, the thematic area where you are looking. You can just try to find in all of the areas at the same time, no problem there. And then all the topics will be listed on your right. Then build a consortium. Don't be afraid to collaborate. There are several ways to get the partners. Obviously, go to the partners that you already know from your network, but we can help you to find partners, indicating you some partner search tools, some databases, but also very important. I personally enjoyed this a lot. The partnering events, the brokerage events, and the info days are probably the best way to find the right partner for your project. So obviously you have to write the project as a consortium. Don't let the coordinator write the project proposal by itself. Everyone should make a good contribution and go to the submission platform and just submit it. These very few administrative documents are needed, so the hard part has passed, and the submission platform is just as easy as clicking on the topic call that will lead you to the submission platform. Now, also as important, please get involved also with us. We are here to try to answer all your doubts here today, tomorrow, whenever you feel like. So we have also newsletters in the contact list that it is very good not to go to the spam, please, because we select very useful information, very concrete information about opportunities for funding in several areas of research, the ones that you tick when registering in here in our contact list, and also the events, for instance, those info days and brokerage events to get more information on these funding instruments and getting more information on how to get partners for your project. So don't be afraid to do it. We are a lot. We are responsible for several areas, and just contact us if you need to know a little bit more. Thank you.
Thank you, John, for the wrap up and the overall view on the funding for people working in energy, both in industry and academia. So actually, I have a question myself. I think we have still 5 minutes to go. Specifically on startups that work on nanotechnology, is there any sort of channel within the new program? I think it's the new Horizon Europe, for them to finance them to jump to the next level, or it has to be like in a mix with all the others? Any idea on that?
Yes, I can advance on that. So most of the projects that or project calls that I talk here is to collaborative projects. But imagine a startup, or even just a group of people that wants to build a startup, or a startup that wants to be a scale-up and so on. There are programs for that. For instance, the Pillar 3, as I mentioned, Pillar 3, Innovative Europe, has funding for these kinds of projects, funding for startups that want to put an innovative solution into the market, and programs for startups that want to grow as a company. So the first one, more focused on the development of the technology and putting the technology on the market, is dealt with the European Innovation Council. And then we have the European Institute of Technology, the EIT, which deals with leveraging synergies between research, business, and also networking and investment, which helps groups to create startups, startups to be scale-ups, and so on. So they help these groups or startups to get investments, to get business coaching, and to grow by themselves. I know that this can be somehow confusing, and it is because I'm like mentioning the 95 billion euro of opportunities in 30 minutes. But if you have any doubts, it is a good thing, because we are here and we have lots of different people that is responsible for all of the different programs. And there are no difficult questions, neither of very easy questions. If you have doubts on, I don't know anything, and please explain that again, it is also good for us. And I know everything, but I need a specific opportunity, just like you said, to grow my company. It is also good for us. Just use us to just for research needs or for company needs. We try to help in every perspective possible.
Yeah, thanks very much. I think this is very important to be clear for the startups, because as you know, they just survive because of this sort of fundings, and even to jump up to the next level, they may also need this sort of fundings, otherwise they die in the middle of the park. Exactly. Thanks very much. I will just raise one more question now. Do you have any idea what fraction of financing goes to Portugal within the new framework? And any numbers?
We will have in a few days.
All right, it's still not available.
It is not publicly available. So the results of some thematic areas will be out in December. So after that, we will make our analysis, and probably will publish in our LinkedIn, in our newsletters. So soon, very soon.
All right. Thank you very much. I think now we jump to the roundtable session. We will have some Q&A as well. So I will just there is Killian with me, and I'm not sure, Killian, is Professor Peter Lund with us? Yes, he is.
Yeah.
Hello.
Yeah. Hello.
Hello. How are you?
I'm fine, and it was very interesting to hear the presentations, indeed.
Thanks very much for being with us. So at least I will introduce Professor Peter Lund as well, and thanks for being with us again. So Professor Peter Lund is Professor in Engineering Physics and Advanced Energy Systems at Aalto University in Finland, and he holds a PhD in Physics from Helsinki University of Technology. He has close to 40 years experience in energy technologies, innovation, systems and policies. He is active in senior roles with European Union initiatives in energy, and he chaired the advisory group Energy of the European Commission. He was chair of the Energy Steering Panel of European Academy Science Advisor Council, past member of the UK's and the European University Association's energy platforms. And he co-chaired several other sessions and activities in the energy sector. So he's actually a very knowledgeable person, and it's good to have him with us. So now I will share just a PowerPoint where I try to collect some questions that I think fits into this roundtable session, and I ask all the speakers to be with us, and Professor Peter Lund, I hope you can moderate this. So now I'm going to share the PowerPoint. So this was a question. I think you can see it now. This was a question raised in the very beginning from Jonathan Ruiz. and they ask that since the Tokyo Paris Agreement has it been an observable decrease in the emissions, there is a sense that targets set on previous agreements were never met, and so Glasgow Agreement might fall short as well. So I think it's a good question to be commented here, and maybe Professor Peter Lund, please go ahead if you can.
Okay. Thank you very much for the invitation and also for a very good question. First of all, decreasing the emissions is not easy if you think about the global reach. And since the Rio conference 1992, the emissions have increased by 50%, even though we knew that we need to reduce the emissions. But there's also some positive signs. So let's say during the last 5 years, the emissions have stagnated. They are leveling out, and now the main challenge is to get them down. And that was about the Paris Agreement. That's the target, of course, in Glasgow. Also, I think there was some good steps on that, but we're still not on the right track, so to say. The challenge is that we need to halve the emissions every 10 years now till 2050. 2050, we have to be carbon neutral, meaning that around 80% of the emissions need to be reduced from today's level. The hope is also, I think, signaled by the countries. Most of the countries, the large continents in the large countries, they commit to the Paris Agreement. So there's a clear trust to do something. Now, will we succeed in this? This is another question, and that's where we need a lot of work and money. But I think the governments worldwide, they realize the urgency, and in that sense, and also the technologies seem to be much better. The base is much better than we had during the Kyoto Agreement. A huge leapfrogging in renewables, in batteries. We're seeing nano also becoming more important in many of the technologies. So I think there's a lot of good signs, but indeed we need to take more stronger efforts in this emission reduction.
Yeah, thanks very much for your comment. I completely agree. I think there is a lot of money needs to put into place for this to go fast, because 2050 is not that far anyway. So let's see if we can So I'm not sure. For example, Claudia, would you like to comment on this as well? Because it was raised actually for you during your talk.
Surely I couldn't answer better than the answer that has been already given, but it's clear that in the last 5 years something has been changed. No, so there was a lot of hope raised by the observation of the greenhouse emission from China in the period 2014 and 16 that showed the possibility of decoupling the growth from greenhouse gases emission. However, this level of emission rises sharply after 2016. However, things are improving. So the carbon emission, the greenhouse gas emission is leveling. So we are approaching perhaps a plateau, but much more has to be done. Just that, it's like a lot of things that need to reach a critical mass to really happen, no? And this is a process that takes a certain time. There are clear signs that things are going to improve. No, there are more commitment also from the private sector. We know that more than 1,000 big companies now are aiming at reaching a zero carbon emission sustainability. No, so they are trying to find solution to decrease the carbon footprint, because that is a business card that they can sell. No, so that's something that's really important. But in Europe, for example, we see that the major cities are trying to adapt and building a more resilient structure. So that is something also good. Financial institutions are removing their support to fossil fuels company, no? So that it's important. Technologically, we made enormous steps in the last 10, 15 years. It's enough to look at the solar photovoltaic or offshore wind and offshore onshore wind farms. So there are development that are making affordable to shift to renewable energy sources. Still, fossil fuel are cheaper, but once that the state will remove their support, economical support, you know, they, at least for solar photovoltaic and offshore wind, no, and onshore wind, you know, we are close to be more convenient. Of course, like Antonio said before, these are energy sources that are intermittent and you know, not evenly spread around the globe. So that is it's a problem that has to be solved now. So we have to find the solution for making these energy source more exploitable. But we are on the good track, let's say. Still not on the track of 1.5 degrees C over by the end of the century, but for sure we are much lower than the 6 degrees C without doing anything. So, and another really important thing is that in the last few years, you know, also thanks to the European Green Deal, we saw participation of the society through social movement that is getting a momentum. Now that is the, let's say, the seeds of a revolution. Now, the people that will grow now and will grow by example, they will one day reach the moment that they will vote, no? And they probably will be wiser than what we are now, no? So we still see some inexplicable situation where the people that go on power, they have everything at heart less than the environment and the society, no? And that is clearly something that is going to change. In the end, after the Paris Agreement has been done exactly what was planned? Of course not. So much more has to be done. No, but let's say in the last 5 years, something has been changed, and this is it will be visible in the near future. That is what is my opinion. That is what I believe. For sure, what we need is more solidarity and trying to help countries that cannot afford in reality. No, so we say that a lot of money were made available to support the development of countries that cannot afford a loan. Unfortunately, so far, the money were made available, but not as a form of grant, but more as a loan. And loan is something that later you will have to pay, no? And that it's not something that is helping very much the developing country. That is an issue that should be solved. But I believe that a lot has been done, and the importance of this summit, of this meeting, is to raise the awareness of what is happening. Part of the society has been always in the dark side. No, they don't know exactly what is happening. And what happened in the state or in Europe or in US is something that is not clear to everybody. So I believe that also through the institution, through the this social movement, or for example, the European Climate Pact ambassador, that it will be possible to bring the people from their living room to the European community, or where it's important to be. So I'm quite positive that the next 10 to 20 years will be a period of a revolution, of a green revolution.
Yeah, thanks very much. I completely agree. I think when we have a society in general with us, who are scientists and people who believe in the transition, things are much easier, I think. And it seems that governments and citizens, they start to understand what are the positive things in this transition, because they can see that they see better in a clear way what is surrounding them. I'm not sure anybody else would like to actually give their opinion on the subject.
If I may just very briefly comment, I think what
Sure.
Claudio said is very important, is that the energy transition is not just a technical transition where you change the old technologies with new technologies, but it's a social technical, it's a societal transition. Everything in the society changes. And this is very important to recognize that we have to look on the social questions. shows of solidarity, as Claudia said, but also acceptance of technology. When you change the technologies, infrastructures, it's always, you have the NIMBY effect, and the acceptance may not be there. So you need to address, in a way, technologies, policies, and social issues all simultaneously. And these need to, be synchronized. So even though you have the best technology, but if people don't accept that, there would be no solution. And that may be important also for the research that when we develop new technologies now, is to keep in mind the end goal, where we need to discuss more with the people and have also interaction with people when we develop technology, so that it will be acceptable. And in that sense, this kind of more people-centric transition is something definitely new, where we need to put people into the middle point. So far, people have been always very often decoupled from energy, or decoupled from energy policy. Now you need to bring them back, and that is an interesting kind of experiment, so to say. And I think that will bring the local solutions, when people have the power also to say something.
Yeah, I agree. We have actually one case in Portugal that actually goes into that direction, is the exploration of lithium, and the government didn't really manage well to include people in this scheme, in this channel, and people are not happy with that because they just don't understand, and then there are a lot of uncertainties in their brains because things are not clear for them. So yeah, thanks very much. Let me ask Professor Di Chazo, would you like to add something here?
Di Chazo had to leave us, Guilherme.
Okay, he's already gone because I don't see it here.
Yeah.
Okay, so then
I just want to add a word to what's just been said here. I think in the past we've had several promises of revolutions in terms of food production, medicine, education, wealth distribution throughout the world. And I think those of us growing up now, so in their early 20s, should go and read history and see where we failed in the past in trying to implement revolutions, and try to learn from the past to try to implement this new type of revolution, which we're talking about here, where we're going to have to help other nations to also follow the path that we want to follow. And what I'm thinking is, so far what we've seen could probably be said to be the low-hanging fruit. So the policies we've tried to implement hasn't really bitten into people's wallets so far. Okay, they see effects, but the effect in their wallet, and I might not be seeing now the people that were hoping to vote green in the future. And we really need to think about that message in the future, is to ensure that people are behind in this policy push that we're doing, to not get a what's the word? Not have, I forgot the word, but when something smacks you back in the face, you push so hard, it swings away and then it comes back straight at you. Because people might vote with their feet and just want to vote for something which solves, or populist type of solutions to solve in the near term. So we need to be careful of that, to make sure that the type of message we pass is sustainable, and one that's based on what we can learn from the past as well.
Okay, yeah, thanks very much, Killian, for your intervention. Yeah, very clear. So what do you think? Can we move? I have another question raised by an attendee in this, and I think it actually fits well into this European Union movement towards the ensuring the critical, like the delivery and exploration of critical raw materials in Europe. So what Francisco Costa asks is, in terms of raw materials and battery manufacture, is it okay, the battery swapping systems? I think this will suit well Valera because it goes into the direction of his talk, but there is very much here about the critical raw materials that we have to think wise very in these programs as well. Valera, would you like to give a word here?
Yes, certainly. Well, it's a very good question, because it touches upon something that Guilherme just said, that we must, well, this is connected with what Professor Lund said as well. We must handle this with care on materials, because we do have a lithium popular problem in Portugal, the NIMBY syndrome. Now, but in a more general way, this is a very good question. Besides raw materials, it takes a point on battery swapping. That's from the few seminars that I've given about this. One of the questions that always pops up is, well, won't we need a lot more batteries, a lot more lithium to do this? Well, and my answer is, let me rephrase the question. It's not how many more batteries we need, it's about 10% more. As I said in the beginning, 10% of the batteries will be on battery swapping stations being charged and rotated with the batteries on board, on wheels. But the question is, how many more batteries do we have to fabricate every year? And as it happens, well, we are not certain about this. We just estimated the effect. But one of the biggest limitations on battery lifetime is fast charging in uncontrolled temperature conditions. So that spoils batteries, that decreases lifetime enormously. Now, if we are doing slow charging in a controlled environment, which is what happens in BS, then perhaps the number of the fabricated batteries per year that we'll do is probably more than with, say, plug-in, is probably zero or even negative. That means we may have less need for raw materials in battery manufacture in BS than with a similar system with batteries like plug-in. So that's, in short, my opinion and my answer on this.
Thanks very much, Valera. I hope you are right, actually. So, yeah, because it actually may solve a lot of problems we have regarding this. Professor Peter Lund, would you like to jump in and have a word on these critical raw materials?
Yeah, I think the issue of materials becomes very important, because if you look on the future energy system, it is material intensive and material based, also data centric. So we're moving from a fuel based into material data based energy system, and unfortunately Europe is lacking many of the, let's say, very important materials like rare earth metals. And also, well, in lithium maybe not that critical, but in some other metals like cobalt, we are there. So I think that's where the researchers may need to step in much more stronger. We may need to improve the efficiencies of the technologies. That is, we need less material, recycling, circular economy, maybe changing technologies, and maybe also taking a leap from the materials, like replacing lithium with sodium maybe in the future, if it's on the batteries. So I think it's really here where the science need to step in and research to provide this more broader material base and be more efficient in the material use. And I think that's where we never did think about this. Let's say 10 years ago, that we need so much materials to change the energy system. So in that sense, I'm positive also here that the research can do much more and help. And it's maybe also about technology choices that we need to do. For instance, with lithium batteries, we're changing now already lithium cobalt into lithium iron phosphate. So we're dropping off the cobalt with another battery chemistry, and that's where the research helps very much. So I think it's a very important question, but I'm also positive in the sense that research can provide out here also some very important solutions to the problem.
Yeah, thanks very much for your intervention. Yeah, very inspiring comment, and yeah, let's keep it in mind, all of us. Dr. Claudio, would you like to give a word on this as well?
Yeah, actually, I totally agree with with Peter about the fact that Europe is lacking enormously many of the important future elements or materials that will make a difference in the developing a sustainable economy. We have also to think that while developing new material, we should already apply, let's say, circular economy and cradle-to-cradle strategies, because whatever we have to do, or we will do, has to be sustainable. And if we think that we can get the elements that we want from other countries that often are poor countries, we're making an enormous mistake, because the mining behind all this new material, it's carbon intensive. So if we think only the extraction, it's as a carbon footprint that it's enormous. No, so and moreover, the treatment that this material have to undergo for reaching the purity that we desire, or just to synthesize them, they are carbon intensive. So if we want to achieve a final goal of a fully decarbonized economy, we have to really keep in mind the possibility of applying circular economy strategy and cradle-to-cradle strategy. Otherwise, we lose the focus. We point at something, but then we obtain something else.
Yeah, I completely agree. Thanks. I'm also very curious about how the mining and refining technologies will help on reaching this, because they are very intensive and in terms of energy consumption. So I hope we will get something better in the next few years on that. Killian, any opinion here, or shall we move to the next one?
I think we can move on.
Yeah. So then we have actually, I think this will touch more Professor Valera. It's from Pedro Benedicto. So would it make sense to make this study, the battery swapping, looking at integrated impact together with Spanish electrical power system, since the last bit of achieved balance relies on availability of energy capacity to import or export to that system in case of Portugal? Valera, would you like to comment on this?
Yes, sure. Well, I think it makes all sense, of course. Actually, I've applied this model to Portugal only because it's the only country that I had the data on. But it makes all sense to extend this sort of study to ever other countries, other geographies. Spain is an obvious choice because really the Iberia is an island because our connections with France are still quite low capacity. So it makes all sense, even because to see how much of these problems of correlation between Portugal and Spain, how much they really affect the problem. This is really an interesting question. And of course, we should do this together, Portugal and Spain. Then I would like to extend, or I would like other people to go on and apply this to quite different geographies. Say, for instance, I read the question about nuclear power. Well, I don't think we need nuclear power in Portugal at all. I've always been, as you saw from my slides, we don't need nuclear power to stabilize or even satisfy energy. We have plenty from renewable sources. But if we go up north, I would be very curious to see what solutions should or might, say, the Netherlands, say, Finland, opt for. Does nuclear have a future in there? We cannot not say no, of course. We should keep everything on the table, but we should make really an effort to compare different models for generation. So, so I would like to see this sort of approach that I've done to Portugal to be applied in several countries, with different structures, possible structures for the energy matrix. Well, So I think I've answered the question.
Okay, thanks, Valerio. I knew you would like to answer this. Anybody else with an opinion about this?
If I may very briefly comment on general on the integration, I think this is a very important question. If you look on Europe as a whole, so because the broader geographic integration you have, you will smooth out the differences, and it may be that we have a lot of, for instance, solar in Portugal and wind in the north, so you can really kind of swap also energy through Europe. So I think this European integrated market would be important. Now here in the north, in the Nordic countries, we have a common market since 20 years. And it has worked very well, and we can, when we have a deficit here in Finland, Sweden can supply us, and vice versa. And in that sense, it is a very good use of the assets, and in particular for this intermittent renewable, like solar and wind, where you need smoothing effects, and that's this geographical coverage that gives you a automatic smoothing effect, and it would be very useful for Europe. And I think this is a step to take, and I think this is also a step that European Commission is taking, gradually moving to an integrated European market. And I think that will solve many of the questions of flexibility and supply and demand mismatch that we may have in the future. I think that's a very good and important question.
Yeah, I completely agree. Thanks very much for your intervention. Anybody else here?
I have a question for Peter.
Okay. Yes.
Peter, what is the public view of Finland's investment in nuclear energy?
I think altogether it's about 50-50, pro and against. So it's been kind of ambivalent in that sense. There's people who say that we wouldn't need nuclear, and other people say we need. For instance, the neighboring country, Sweden, is now dismantling nuclear. They used to produce 50% of their electricity with nuclear, and now it's coming down. And by 2040, they're replacing it with renewable electricity. Here in the Nordic region, over 50% of the electricity hydropower, and that's a huge battery, so to say. And that enables you to produce also a lot of wind power. Solar may be not that important here in the north, but a lot of wind. And I believe myself that wind and hydro as a combination can do the same as nuclear in the energy system. And that's how Denmark and Sweden, for instance, is doing. Finland is leaning more to nuclear energy, but I think from the energy system point of view, that would not be necessary. Also, nuclear is pretty expensive. I think that's the main concern. It's about double the cost of wind energy already. So the cost is also a question which I think should be a concern when we look on nuclear energy.
So with the neighboring countries, Sweden and Finland, why do they have such contrasting views to nuclear?
Yeah, I think that the question, first of all, in terms of the solutions that you have, there's many solutions to the energy transition. And I think in our case, it's very much an industrial case in the sense that 50% of our electricity goes to industries. We have the heaviest manufacturing industries in the OECD countries. So the industries, they prefer very often nuclear. It's a kind of power plant, easy to so to say, to control and to manage. And their hearing and their word is very strong in energy policy. I think it's very much a societal question more than a technical or economic question. It's about.
So industry is very conservative.
Yeah, very conservative, and in Sweden that would not be that conservative. So it's a societal question. I would say, not a question about economics or missing technologies, but it's more a question about the societal question. So that's where we see the societal side of the transition sometimes leads to these solutions as well.
Okay, thank you.
Yeah, thank you very much. Thank you very much. Yeah, I know that most of the energy comes from hydropower there, so yeah, there is a relatively easy solution for you there. So I think we have reached it's 5 p.m. now. Killian, shall we just close the session, or we can ask one more question?
I think we have time for a bonus question, but we have lots of nice questions, but we have to finish because people have to go, don't they?
Yeah, exactly.
Unfortunately.
Exactly. So then we just close the session, I think. So yeah, just stop sharing. So before we leave, actually, I would like to thank all the speakers for being with us. So without you, it's never possible to do these kind of things. And I hope that attendees manage to get some ideas and manage to keep some messages in mind, and also being aware of the funding opportunities at least at the European level that they can try to rise in the near future together with colleagues. I'm not sure if I should just maybe just say goodbye, and I would like to say that we have a great PV day tomorrow. So we'll have a lot of good research and industry involved in, and I hope you can all join us. It will certainly be interesting. Killian will lead the session, and we will have a great one, certainly. So with this, I think we just finished in time, and I thank you all again for being here with us, and I hope to see you in the next time, so hopefully tomorrow. Okay, thank you very much.
Thank you.
Thank you very much.
Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you.
Bye.
Bye-bye.
Bye.